Hello, everybody, and we have a Squircle limit today that will hopefully convince you that as x goes to 0 in the limit of 1 over x squared, or 1 over x factorial squared divided by 2 over x factorial, that we do indeed get 0, because that should be consistent with what we expect for the Squircle formula. Maybe in the future I will do something with other coefficients besides the 2, generalize it, but for now we'll stick with the 2. That'll be good. Anyway, getting started, the first thing I'm going to do is a quick substitution. So I'm going to say u is basically going to be 1 over x. So in a way we're doing a u sub. Basically meaning that our limit now goes from, instead of approaching 0, we're going to be, u is going to be going to infinity, which also makes our factorial terms quite a bit nicer, because we just have u factorial squared divided by 2u factorial. Now, this is very tempting just to be like, oh yeah, can't you do some cancellation stuff? And no, the answer is no. We're going to have to kind of get through this. You could do like Stirling's approximation. We're going to be doing something kind of similar. But anyway, this is kind of a fun one. So I'm actually going to stick with, we're just going to kind of assume that u is an integer right now. We're just going to kind of assume it's an integer. So that way we can use the traditional definition of a factorial, basically meaning that our numerator is going to be u squared times u minus 1 squared times u minus 2 squared. And then we're going to have dot, 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 2, 1. And then on the denominator, we're going to have 2u times 2u minus 1 times 2u minus 2, etc., until 1. And it's a bit tempting to look at this and say, well, if you compare this like term by term, it might seem like it doesn't actually converge, or it might converge to a value, but it actually does. And the reason for that is basically because, let's just real quick, just based off of this definition, just compare the order of terms, or the leading coefficient, not leading coefficients, the leading terms. So it's the highest order terms. So you'll notice here that we will have, on the numerator, we're going to have u minus 1 terms with a u in it, more or less. And on the denominator, we're going to have 2u minus 1 terms. The reason it's both minus 1 is because we have 1s here. So basically, if we just kind of ignore all the FOIL stuff, because this is the limit after all, what we get is actually, on the numerator, this is basically I don't want to write equals, so I'm just going to like do this, I guess. It's basically equivalent to u squared to the u minus 1, and the limit still applies. And on the denominator, we have the same thing, kind of. Just for leading coefficients, we have 2n to the, 2n minus 1. And when we phrase it this way, the limit actually seems not terrible to evaluate at all, actually. You could actually just look at this and say, oh, it goes to 0, and you'd be perfectly right. But I think it would be helpful to go a tiny bit further with the math. So what we're going to do is say, I'm just going to use properties of exponents at this point. So the limit as u goes to infinity of, let's see, u to the 2n, or sorry, 2u to the 2u minus 1, or minus 2, I'm very sorry. Doesn't really matter actually, but it's a minus 2. And then in the denominator, we're going to have 2 to the 2u minus 1. And then we have a u to the 2u minus 1. And then just comparing our u terms here, we can combine the u's into one u, meaning that our exponent is just going to be u to the 2u minus 2u minus 2 plus 1. This right here is just 1 over u, meaning that our limit is actually equivalent to u as u goes to infinity. Our limit just reduces to 1 over u to the 2u minus 1. which quite evidently uh, very much goes to zero, and quite quickly, in fact. So yes, this is just kind of like a short video, kind of explaining why, as n goes to zero in the Squircle formula, uh, we end up with zero area besides just looking at it graphically. So I hope y'all enjoyed. Hopefully in the future I will be able to do this after the n-dimensional video. We'll be able to do this with any power, so like 1 over x factorial to like the k or something. But it'll be for another video, and that will also be a similar method and pretty fun. So yeah, hope y'all enjoyed, and I'll see you in the next one. Adios.